In Algebra 2, you discussed what radians and degrees were. Okay? Radians is a different way to measure angles that actually, they work out a lot nicer than degrees. Okay? You may not think so, but they're actually more useful. Okay? So a radian is defined as the measure of a central angle that intercepts an arc S that's equal to the length of the radius, blah, 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 blah. Okay? So when the radius equals the arc length, then that means you have 1 radian. Raise your hand if you remember talking about radians at some point. More than likely you remember radians with the pi symbol attached to it. That doesn't mean it is a radian. Okay, the difference between radians and degrees have the degree symbol, radians do not. A majority of the time, yes, you will see a pi sign attached to a measurement, but that doesn't mean that if there is not a pi symbol that it necessarily is a radian, okay? It's more, is there a degree symbol or is there not? Okay. Okay. Basically, a radian is measured as the arc length over the radius. Okay, you're really not going to have to necessarily know that, but that is how a radian is measured. Okay, let's talk about how that's helpful for how we can convert back and forth. Okay, how many degrees are in a circle? Okay, how do we measure the outside of a circle? Circumference. And how do we measure that? Try again. Pi b or pi times 2r, right? Okay, so if we use the fact that a radian is the arc length, 2 pi r, over its radius measure, then there are 2 pi radians in a circle. Okay? So 360 degrees is the same as 2 pi. Or, cut that in half, 1 pi would be the same as, okay, 180 degrees is the same as pi radians. That is going to be what is going to help you convert from radians to degrees or from degrees to radians. Okay? So we're going to flash back to science class for a little bit here. Okay. I have 120 degrees. I want that to be in radians. Okay. We need to multiply by a fraction where what is in the denominator? Okay, we want degrees in the denominator because we want them to be able to cancel out. Well, we know that 180 degrees is the same thing as pi radians. So our degree cancels out. And now we have, technically, we have 120 pi over 180. I don't really like that, do you? No, I would expect you to reduce that down to 2 pi over 3. What about going the other way? Let's see, what's my example here? 7 pi over 9. If I want to convert that to degrees, okay, any type of conversion, you're going to have to multiply by a fraction, right? This time, what is our fraction going to be? Okay, now we want the degrees, so that needs to be in the numerator. We don't want the radians, so those need to cancel out. Now, radian doesn't have like a label, so you're not going to see like a label cancel out like you would with those degrees. But conveniently enough, there are pi's that cancel out. Okay.
Oh, isn't this something to like memorize last year?
There will be some stuff to memorize. Okay. What's 180 divided by 9?
20?
Times 7?
What?
Is there a question? Okay. Can you convert? Okay. Will you maybe need to practice a couple in our homework tonight? Probably. Yes. But we'll be able to get there. Okay. Now we've been talking about angles. Let's talk about actually like plotting them. Okay. Anytime we graph an angle, we want, well, in standard position, we want its initial side to be on the positive x-axis. Initial means that's where it begins. Okay? And then the terminal side could be on any one of the axes or any one of the quadrants. Okay? So what I want to remind you these are our quadrants. 1, 2, 3, 4. You will be asked to tell me like which quadrant an angle lies in, so it's important that we know or we recall where those quadrants are. Okay? Now, let's talk about degrees first. That's easy for us to picture. If we start here and we rotate up here in between quadrants 1 and 2, how many degrees would this be right here? And then we rotate some more. And then we rotate some more. And then all the way around we said was 360. Okay? So if you have an angle measurement between 180 and 270 degrees, its terminal side would lie in the third quadrant. Okay? We got to get our mind adjusted to radians, however, because a lot of what you deal with in this chapter and the next chapter will be radians. Okay? So we start here at 0. If we rotate to 90 degrees, 90 degrees is half of 180. So in radians, 90 degrees would be half of pi. Okay? 180 degrees we said was the same as pi, so when we rotate all the way to here, we have pi. Okay? When we rotate another 90 degrees is the same thing as pi over 2. So this right here is 3 pi over 2, and then all the way around would be 2 pi. Okay? Yeah, you're going to have to think in fractions a little bit. Okay? But we have fractions times pi. If we think about the fractions, we can figure out where they go. Okay. So let's practice plotting a couple angles. Okay. This is nothing new, correct? We talked about this in Algebra 2. All right. So these are the two angles that we need to plot, in degrees at least. 120 degrees and negative 750 degrees. Okay. Let's start with 120. Here's where we begin. 120. Which quadrant would that lie in? The second one. Probably closer to 90 degrees than 180, wouldn't you say? So notice how I draw the terminal side. I draw an arrow of rotation, and I label my angle. Okay. Now, in part B, we have a negative angle. Negative. That means we're going to have to rotate what? Okay, we are going to have to rotate clockwise because that would be the opposite direction. Now, is 750 bigger than 360?
Yes.
It is. So this is going to be more than one rotation. Okay? So here we go. All the way around once would be negative 360. All the way around twice would be what? Negative 720. So how many more degrees are left? Okay, so now after we've gone around twice, we need 30 more degrees in the negative direction.
Why don't you go down to the up?
Because we're rotating in the negative direction. So if it were positive, we would rotate up. But since we're rotating negative, we would keep going in that direction. Party time. I am fully confident that you guys can plot these. Okay, I am going to talk about them with you, but I'm fully confident that you can do it. Okay. Okay, so as long as it has a pi in it, we can think about the fraction and worry about the pi later. So all of our axes have a rotation involving pi, right? 1/2 pi, 1 pi, 3/2 pi, blah, 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 blah. Okay, well, let's just think about 5/2. Is 5/2 bigger than 2?
Yes.
So 5/2 pi is bigger than 2 pi. Would you agree? Okay, so we're going to rotate all the way around once. 5/2. Once we get 2 taken care of, there's only 1/2 more. Do you agree? So when we're thinking about 5/2 pi, once we've taken care of 2 pi, there's only 1/2 pi remaining. Now, if I were to plot the angle pi over 2, would my terminal side be in the same place? Yes or no? If I plotted the angle pi over 2, would my red arrows be in the same place? They would. We're going to talk about what that means here in a little bit. Okay? 4 pi over 3. As a pod, who's just had a nice bonding moment. Come up with a common answer. Which quadrant is this going to lie in?
One is 1/8. It's 3/3, and then an extra third. You gotta change it like it's a rotator.
All right, Dallas, which quadrant?
Quadrant 3.
Quadrant 3. Explain that.
Well, I think 3/3 is 1, and 1 pi is 180 degrees. So Max just said, like, think of the extra third as a remainder, and then dividing upon 3.
Okay, so 4/3 is bigger than 1, right? So 4/3 pi is going to be bigger than 1 pi. Okay, but not quite as big as 1.5 pi or 3/2 pi. Okay, there are going to be a lot of important angle measurements, and you'll see a drawing like this again on Thursday. But I just kind of want you to have this visual. If you want to like tape this in your notebook somewhere, I think that this would just be a good thing for you to kind of start to get familiar with. Okay. So there's like 16 angles on here, I think is what it is. These are going to be very important when we get to the unit circle. So here are where these angles are and what they are in degrees and radians, okay? You should be able to convert from degrees to radians and back and forth, but I don't want you to have to do that with these special angles. But I just kind of want you to start getting your eyes familiar with these 16 angles, okay? All right. Questions about any of these angles before we move on to some other vocabulary? Okay. I'll have tape and staplers available if you want to grab some at the end of class, okay? I need to talk about some vocabulary words. So I'm going to give you about 60 seconds to see what you can come up with for these 4 words.
Okay, so wait, can you go back to coterminal? Coterminal is like we can't figure this out. Well, you probably have lines, you know? Tell them the lines. You don't know if it's right. There you go. So we're not, we're kind of.
Circle.
Oh, it's a part of a circle, like a slice of pie. Because like an area of a second. Slice of pie.
Who's still working?
Okay.
Guy, what does it mean to be complimentary? Add up to 90. Add up to 90. That degree symbol is very important. If it's not there, I assume it's radians. Okay? Now we also are talking about radians. So angles that add up to 90 degrees, or 1/2 pi, not 1/2 radian. Okay. Supplementary. Max, how about you tell me that one?
Angles that add up to 180 degrees or pi radians.
Okay. My N had to get squished in there, sorry.
Angles.
It's fine. It's fine. Angles that add up to 180 degrees or pi. To be very honest with you, the examples that we are going to do will all be in radians because I don't think we need to practice this in degrees. Okay? Coterminal. Okay? That's probably, like these are probably ranked from easiest to hardest as far as recalling from last year. Would you agree? Okay, maybe supplementary and complementary can be flipped. But coterminal, all right, we got to think about a little bit more. Sydney, did Pod 7 come up with anything for coterminal?
We said that we remembered it in something like if you had add or subtract 360 from it,
And it would be
like the same.
okay. So we know that the process is that we can add or subtract 360 degrees, or okay. So Pod 7 kind of has the process for us. Can anybody tell us, besides Max, you've already answered a question, sorry. Can anybody tell us why that is our process? Emily.
They share the same like
Okay. So co-terminal, angles that share the same terminal side, and they're both in standard position. So you know when I was talking to you about the 5 pi over 2 and the pi over 2, if you graph them, they start and stop at the same point, at the same place. They are just different measurements. Okay? And then a sector. Who came up with an answer for sector? Only then? This was the hint that I gave to Max's group. It deals with a circle. What?
part of the
Yep, which part?
part where the angle is.
Yeah, the part where the angle is. Like a slice of pie. That's a sector. I'm just going to draw. Okay. It's the portion that an angle is intersecting with the arc. Okay, an angle is intersecting the arc. Okay. So, let's do a couple examples. 5 pi over 12. I want to know the supplement and the complement of 5 pi over 12. On the slide previous, we defined that a complement are two angles that add up to be pi over 2. So if I give you a value, what do you need to do with it? Okay, so like 5 pi over 12 plus its complement equals pi over 2. Is that kind of what you're telling me?
Yeah.
Okay. Which means to figure out what our complement would be, means we would have to subtract that over, right? Okay. Now, we can't really add or subtract unless we have common denominators, so I would suggest thinking of this as 6 pi over 12. So that we get pi over 12. Okay, let's make common denominators. Common denominators will be your best friend with radians in this unit. Supplement, how is that going to be different? They need to add up to be pi. Okay, so if we're going to calculate our supplement, we're going to take pi and subtract 5 pi over 12. Okay, once again, I would highly suggest making a common denominator, so writing this as 12 pi over 12, so that your supplement ends up being 7 pi over 12. Some of you can make common denominators in your head. I'm fine with that. Some of you like to write them down. I'm fine with that. You do what works for you. Okay? But I was at least write down what you did. Pi minus 5 pi over 12 equals 7 pi over 12. Okay? All right, so we talked about coterminal angles here. I'm pulling all my screen sheet down all that way.
That's how he treats it. He gets his workouts from that stuff.
Okay, we're going to talk about our coterminal angles here. So if you want to write coterminal in 70 degrees. Okay, now Emily told us, okay, we have angles that share a terminal side. Pod 7 came up for us. And we add or subtract 360, we add or subtract 2 pi. Okay? So let's talk about 70 degrees. Which quadrant does 70 degrees lie in? The first quadrant. Okay. Does that look like 70 degrees? Okay. So what's going to happen if we take 70 degrees and we rotate an extra 360 degrees, we're still in the same place, aren't we? Okay. So if we take our angle measurement and we add a rotation, we have a coterminal angle. Okay? We could even do it again, right? If we take 430 degrees and we rotate a full rotation, right? Then we have another coterminal angle. Okay? And really, we could be obnoxious, right? We could keep adding 360, adding 360, adding 360. Okay? Yes, we could also subtract 360. Okay, I'm going to draw a new picture because I don't want this to be too busy here. So here is 70 degrees. From the terminal angle, we could rotate in the opposite direction, 360 degrees. Okay, so you can see here we have this angle. So we can say 70 degrees, subtract 360, and we would have a negative 290 degree angle. Okay, and we could be obnoxious again. We could keep subtracting 360. Okay, I think your book is going to ask for one positive coterminal angle and one negative coterminal angle. So just make sure you add or subtract 360 degrees enough times to be able to get one of each. Okay. Okay. Let's do one in radians just for the practice. 3 pi over 4. Before we talk about its coterminal angles, I want you to graph 3 pi over 4 for me. Braden, where does 3 pi over 4 live? Quadrant 2. And it's going to split it, right? 3/4 pi is going to be exactly in half from 1/2 and 1. Okay? So here is 3 pi over 4. So to find coterminal angles, we're going to do the same thing. We're just going to make a complete rotation, but this time we're in radians. So we're going to have to add 2 pi. Okay? Just like we talked about earlier, you're going to need to do some common denominators. So think of 2 pi as 8 pi over 4. So a coterminal angle would be 11 pi over 4. Find me the negative one. Addison, what would this one be?
-5 pi.
What's the last thing we need to talk about?
Sector.
A sector. Okay, there's 2 things we can talk about with a sector. One is its arc length, one is its area. Okay, so when we talk about arc length, we're talking about this red piece. So it's just like a piece of the circumference. Okay, so it's the length around a piece of the circle. Okay, and we can calculate that by taking the angle theta and multiplying by the radius. Austin, read me what I just boxed in red. That's theta.
Theta is the angle in radians.
Radians. If your angle is not in radians, you have to convert it. This only works in radians because essentially it is the definition of the radian rearranged. Okay, from that very first slide. Okay, your angle has to be in radians for this to work. Okay, and it is a measurement of length. All right, so you're going to have a label. If the radius is given to you in inches, your arc length would be in inches. If your radius is given to you in feet, then your arc length would be measured in feet. So let's say theta is pi over 6, and you have a radius of 2 inches. Then your red arc length would be pi over 6 times 2. Okay. Somebody with their calculator out, I think Riley, Max, oh, there's 2 with calculators out. Take pi over 6 and multiply it by 2 for me. Okay? Yeah, I know it's pi over 3, but I wanted a decimal form here.
I got 1.047.
So our arc length would be 1.047 inches. Okay. And that is how long this piece right here would be. Okay, that red piece. Okay. We're not going to do an example, but we also can find the area of the slice of pi by taking 1/2 theta r squared, where once again theta is in radians. You made it through your first math class of 2019. Okay. The 015 sheets, if you could just place those in the recycling bin for me, I would appreciate that. If you want to tape or staple, I'll put those on my front table for you to grab. Here you go. That's a great question. Anything from last semester you wouldn't necessarily need unless you want to keep it for reference next year. That will be the only thing. Okay? So this is a new semester. We're starting fresh. You're at a 0.
Yes.
Some of you like to think it as you're 100, but you really have nothing in the grade level. Okay? Right. Okay. So we will have this Friday. And a worksheet. So I will get you what you need. Okay.
I'm going to change the pottery, so